That is, a particle will move in such a way that its distance from a fixed point is always same. Yeah? One particle is here and any point it is here. After some time it has gone to this place. So distance of this point, this object from a fixed point is always same. Naturally, the path will be circular in nature. So particle is moving on a circular path. That we have done in class 10 also. This fixed point we call center of the circular path. It is not needed the whole circle is required. No, it may be small part also. Suppose like this, it is moving from this place to this place. So its distance from here is always same. Like particle has come from A to B. So this OA and OB are equal. So this is also circular path, circular motion. So particle may move on a complete circle or maybe a part of circular path or part of circle. This line joining the center and position of the particle we call position vector, or as the magnitude is equal to radius, so it is also called radius vector. So suppose this is the radius r. So OA is the position vector or radius vector. Suppose at t equal to 0, when we start observing the particle. After t equal to delta t, the particle has reached to point B. So OB will be the radius vector or position vector at time delta t. So whatever angle is made by this position vector or radius vector on the center of this circular path, this angle we call angular displacement. In case of motion along a straight line, we come across linear displacement. That is the shortest distance between initial and final position. Here it is angular displacement. We represent this displacement on the circular path by this angle. Particle, suppose it has come from here to here, this is delta theta, from here to here, and this angle. So this is angular displacement. So angle subtended by position vector or radius vector at the center during whatever the time may be, during the interval of time. So angle subtended by position vector or radius vector circular path during certain interval of time. So naturally, what will be the unit of this angular displacement? SI unit of angular displacement will be, what is the SI unit of angle? As it is measured by angle only. So what is the SI unit of angle? Yes?
Radian.
Radian. So naturally, its SI unit of angular displacement will be radian. So SI unit of angular displacement. Radian. R. What is relation between radian and degree? We are knowing. So 180 degree is pi radian. Sometimes it will be given in degree. So we can convert it into radian. So 90 degree pi by 2, 45 degree pi by 4, like that. This is the relation between radian and degree. Now, angular speed, linear speed, what was that? The rate of change of displacement, that is linear speed. So similarly here, rate of change of angular displacement, that is angular speed. So this average angular speed, here also we have done average linear speed and instantaneous linear speed. So average angular speed is, this we give the symbol omega bar, this will be delta theta over delta t. Unit radian per second. And instantaneous angular speed this omega will be, and we say limit delta t tending to 0. Instantaneous, when we are taking, what we are doing? We will find average for very small interval of time. That is, when the point B is very close to A, when the point B is coming here, suppose like this B. Then what is the average velocity between this point A and B? When B is very close, that is delta t, which time interval is approximately 0 or tending to 0, we say in the language of calculus. So we take that one. Instantaneous speed is also average speed, provided we are calculating the average for the position of the particle which is very close to each other. So this is of omega bar, that is average. So it will be limit delta t tending to 0 of delta theta over delta t. So we write it like this, d theta by dt, or d by dt of theta. Or sometimes we write like this, theta dot, like this it is, means single differentiation. In the language of calculus, sometimes it is written like this, theta dot, means you will differentiate theta once. That is instantaneous angular speed or angular velocity. When angle is very small, tending to 0, then we treated as vector quantity, and it will be along the axis, that is either inward or outward, depending on in which direction you are moving. If you are going from this one, it would be like this, then it is outward. If you are coming from B to A, then angular displacement is inward. Okay, so this is instantaneous angular speed. Now, the particle may move with uniform angular speed or with non-uniform angular speed. If it is uniform angular speed, we call it uniform circular motion. In case of non-uniform, that is non-uniform circular motion. So what will be the unit of omega? Radian per second. Now sometimes this theta will be given in terms of time, and you will be asked find the angular speed at this much time, like linear velocity. We are given this theta is 3t square minus 5t plus 4. Find angular speed at t equal to 3 seconds. Average angular speed for first 5 seconds. Okay, suppose this is like this, and theta you are given in radian, this much radian, and t is in time, second. Then what will you do? When you are asked angular speed at t equal to 3 seconds, that means what is asked? This is instantaneous speed at a particular instant. So to find this instantaneous speed, we will have to differentiate it with respect to time. So, as we know, this omega is d theta by dt. How much it will come? Differentiate this with respect to time. What will be? Yes, anyone?
6t minus 5.
6t minus 5. Very good. So it is 6t minus 5. Differentiation of this 4 will become 0. So this is the angular speed. As angular speed is depending on t, that means it is variable, non-uniform. It is not constant. If t is not coming here, then only we say omega is constant. So in that case, average or instantaneous will remain same. So as it is variable here, you are asked at t equal to 3 seconds. So angular speed at t equal to 3 seconds. What will come? 6 into 3 minus 5. So 18 minus 5, that is 13 radian per second. This is instantaneous speed. Angular speed at a particular time when you are given in this way. Then you have to find by differentiation. Now, average angular speed for first 5 seconds. This what will you find? Average angular speed, how will you find? You have to find delta theta over delta t. So at t equal to 0, what is the value? So at t equal to 0, theta naught is suppose like this. How much it is coming? This is 0, this is 0, this is 4. 4 radian. at t equal to 5, because we are asked for first 5 seconds. So theta is how much? 3 into 5 square minus 5 into 5 plus 4. So what is that? How much? 25 into 3 is 75 minus 25, that is 50 plus 4, 54, no? Now average speed, that is delta theta over delta t. So 54 minus 4 and time is 5 seconds, 5 minus 0. So 50 by 5, that is 10 radian per second. So this is how you find average speed and instantaneous speed.
Sir,
Yeah.
sir, once again, please you explain that part, sir.
So in the average speed, what will be? What is the? This omega bar is how much? Delta theta over delta t. So you are asked for first 5 seconds. So at t equal to 0, what is the angle? At t equal to 5, what is the angle? So what is the change in angle? Suppose we start observing here and the reference line is this one. So at t equal to 0, particle is here at point A. So this is theta 1 or theta naught. The reference line is this one and particle is here. Now after giving 2-3 rotation, it has come to this place. So for each rotation, 2 pi radian will keep on adding. That is the meaning. So we will keep on adding. So after giving suppose 3-4 rotation, it has come to this place. So from again reference line, whatever angle is coming, that is your theta 2. So delta theta, theta 2 minus theta naught or theta minus theta naught by total time. Understood?
Yes, sir.
Like you are taking, suppose this R is given 3t square minus 2t. Then what is the average speed? How you will find? Average speed for first 2 seconds. First 2 seconds means from 0 second to 2 second. So what is delta R? What is the position at 2 second minus what is the position at 0 second? Average speed delta t by delta t you will find. So what is the position vector at 2 second? 3 into 2 square minus 2 into 2. What is the position vector at 0 second? That is 0 only. So this way we find average speed. Did you get it?
Yes, sir.
Yes. So that is the difference, how to find the average speed or instantaneous speed when you are given theta as a function of t. If you are given theta in terms of time, then how will you find? Now, if omega is constant, the motion is uniform circular motion. So in that case, there will be no change in the angular speed. So in that case, average angular speed, omega bar and omega will be same. Average angular speed or instantaneous angular speed will remain same. Now, if omega varies, if it is either increasing or decreasing, omega changes or variable, then we call non-uniform circular motion. So we will discuss, mainly we have to consider this one, but for this also we'll do the relation. We'll find the relation or how to solve the problem of this situation. Okay, so first we'll focus on uniform circular motion. So uniform circular motion. In this case, as we know, average angular speed or instantaneous is same always. So there is no change in the speed. Whether you find average between A and B or whether you find average between A and C here or for complete rotation, no problem. Well, speed is not changing. So if it takes, suppose time period is t second, if particle completes one rotation in time t, this t we call time period sometimes. Time period of simple pendulum is different. Here, time period means time taken to complete one rotation. Complete one rotation or revolution, whatever you may say. So when it completes one rotation, what is the angle subtended? At t equal to t, what will be delta theta? 2 pi. Or when delta is suppose, when delta t is t, delta theta will be 2 pi. One complete rotation, that is 2 pi radian, 360 degree. So what is this omega? So average angular speed or instantaneous angular speed is how much? 2 pi over t. As instantaneous and average both are same in this case, so it will be 2 pi over t. It can be 2 pi n. This n we call 1 by T. That is the frequency. Is number of rotation or revolution per unit time. This we call frequency of revolution. This unit of n that is hertz. Maybe SI unit we can say hertz. So this is hertz, or we say RPS, that is revolution per second. Generally, in circular motion, you will be given like this, RPS, revolution per second. It completes 100 RPS, that is 100 revolution per second. In form of hertz, may not be given. Meaning is same. In 1 second it completes. Generally, hertz is used for oscillation, oscillatory motion, like pendulum. No, in lower class we have done. In case of pendulum, time period is second and frequency is hertz, that is per second. So here generally it will be given RPS, revolution per second. Sometimes it will be RPM. RPM, that is revolution per minute. What is the relation between these two? So if n is or if n equal to 1 RPS, means it is equal to 60 RPM. Or simply like this. 1 RPS means 60 RPM. It completes one revolution in 1 second. That means in 1 minute, 60 revolution will complete. So if it is given in RPM, how will you change in RPS? So 1 RPM means 1 by 60 RPS. Suppose 1200 RPM means 1200 by 60 RPS. Like the speed of fan. If you go to purchase the fan, ceiling fan, they are writing that much. That is, the speed of this one is 1400 RPM. Means it will complete 1400 rotation in 1 minute, or 1200 RPM or 800 RPM. So that will depend, that will give the idea how fast the fan is running. Okay, so this is angular speed. Now, what will be linear speed? In this case, if we are interested to find linear speed, what will be? During one rotation, how much distance is traveled? Yes?
2 pi r.
2 pi r, yeah. So that will be the circumference of the circle. So linear speed will be, here also linear speed, average and instantaneous, both will be same. So here average linear speed, this V bar, or instantaneous linear speed. V, both are same. And this V bar or V will be equal to 2 pi r over T. 2 pi by t. Just now we have got omega. So this v is omega r. So linear velocity is given by angular speed into radius. So we'll leave up to here today. Yes. Any doubt?